Here's another one that, number 3, that you have to get kind of down to the measures. So you have to use the definition of congruence to kind of go from measures back to congruence, and then you can, or back to supplementary at least, and then you can prove that A is parallel to B, right? So by the converse of the same side interior angles theorem, we can say that A is parallel to B, right? So that's what we want to try to figure out, is how do we find that 2 and 3 are supplementary, right? And so that's kind of what we want to achieve. So if we're given 1 and 4 are supplementary, then we can use some vertical pairs, right, to kind of relate 1 and 4 with 2 and 3, respectively. And we can do some congruence definitions to get to the measures of, and so we can say that, okay, well, measure of angle 1 plus measure of angle 4 equals 180, and then we can use some substitution with that to say that the measure of angle 2 plus the measure of angle 3 is equal to 180, and then we can go on to say that they're supplementary by the definition. Okay, so this seems pretty straightforward, right? It might seem pretty obvious to you, and that's good, but once again, we have to be explicit and precise in the use of our statements and reasons. Here's another tricky one. So measure of, or angle 1 and angle 2 are complementary, and 3 and 4 are complementary, right? So we can use that to say that this is a right angle, right? And we can do the same thing over here, or we can say that they're perpendicular. But we have a few steps to do. We have to go from complementary to they add up to, the measures add up to 90, and then we can use a segment addition postulate to say that the sum of those two angles are equal to the measure of KLJ, right? Then we can use some substitution to say that KLJ, or transitive property, to use that KLJ is equal to 90, and then definition of right angle, that it is a right angle, and definition of perpendicular to say that it's perpendicular with IJ, right? And we can do the same thing with MJL, this angle here, right? And 3 and 4. So once we say that these two angles are perpendicular, then we can go from there to do some other things, right? To say that, maybe some angles might be parallel, and then when we say that they're parallel, that opens up the door to prove that angle 5 is congruent to angle 6. Okay, so this one we'll take some steps and some things that you do have to really detail out and be explicit about. All right, number 5, another challenging one. So angle 1 and angle 4 are congruent or equal, right? So we can say they're congruent if we want to. So we know that those are equal. The measures are equal, and we know that line BC is parallel with line ED. Okay. All right. So if these two lines are parallel, these two angles are congruent or equal at this point. The measures are equal. So if these two lines are parallel, then we can say that opens up the door for some alternate interior, exterior, that kind of thing, right? So there's only really one transversal that connects those two lines, right? BD. And so there's two angles that we can work with that are attached to BD. Okay, so use those two angles. All right, I'll let you figure out what those are. And then we want to prove that line BH is congruent with line DF, right? So in order to do that, we have to use a transversal that connects those, right? Which is the same transversal, BD. BD is the one that connects those two. And so then we need to use angles that are formed by that transversal BD and the two lines that we want to prove parallel, right? So the angles that are formed by BH and FD with BD are this angle and this angle, right? Those are really the only two angles that we can see. We could extend, right, and use this angle with this angle, but we don't really have relationships going on with those quite yet, right? We'd have to kind of develop a lot more. So I think this would be the easy way to go, is try to figure out, hey, how does this and this relate? And then how does that help us to prove that the lines are parallel? So we're probably going to use one of the converses, right? Converse of alternate interior, converse of alternate exterior, converse of same side interior, converse of corresponding angles.